Hello everyone, I am Said Purmayet. Welcome to my YouTube channel. In this training, I deliver comprehensive lectures on data analysis using Python. Throughout the lectures, I will present 22 chapters that cover fundamental and advanced topics in the realm of data analysis with Python. Here you can see the table of contents. I start with basic concepts like different data types and how to read data from different resources, how to do filtering, how to clean the data, apply functional columns, sorting, joining tables, group by, pivoting and unpivoting, concatenation, conditional column, cell referencing, plotting, how to read and export data to Excel, CSV, and text files, connection between Python and PowerPoint, how to send emails by Outlook in Python. And in last 7 chapters, I will cover more advanced topics like reading data from Snowflake, SAP, and GDA, and how to do dynamic conditioning, for loops, while loops, and if conditioning in Python, list, tuple, and dictionary, SQL in Python, Python code in Excel, and finally optimization and simulation by Python. For each chapter, I explain the topics through a series of slides and also provide a corresponding Python script in which I elaborate on the topics through examples. And I use also a case study. For that case study, I have some input data. I use Access database and Excel files to read the input data. And I use that case study to explain the topics. I will upload this input data, which is related to our case study, in my channel. Okay, to get started, first you need to install Anaconda. You can go to this web and download and install Anaconda for free for both Windows and Mac version. After installation of Anaconda, you can launch Anaconda Navigator from Start menu. And after launching Anaconda Navigator from here, a page like this pops up where you can see different environments in Anaconda Navigator. JupyterNotebook, Spider, and PyCharm are 3 well-known environments where you can do Python coding. And syntax for these 3 environments are almost the same. In this training, I use JupyterNotebook, which is one of the strongest data analysis tool, especially for plotting and presentation. So to launch the existing script, I just launch JupyterNotebook. Okay, then you have access to your system. Then I launched the script, which is in this path script. Here I can see different script for each chapter, and I launch chapter 1 script, and I start to explain topics through examples by existing Python script. Okay, so again, first install Anaconda, launch Anaconda Navigator from menu, and then a page like this pops up. Launch JupyterNotebook, and then launch your Python script, and you will reach to this page. And if you want to create a new script, that's an existing script that I have. See, we have an existing script for each chapter. And if you want to launch a new script, just go here and just new Python 3, then an empty Python script is created here. So you can start coding from this cell onward, and you can add cells by clicking plus. You can add cell, and each cell you can start coding. So through next chapter, I will explain how to write coding in different cells. And by clicking here, you can rename your Python script. For example, you can say chapter 1 and then a title. I don't know, different data types. And then rename it. So it's the way to create a new script, NTF script, and the way to launch your existing Python script. I put my Python script in the past. So it is the past that I put my Python script. Then by launching Anaconda Navigator, you will reach to here, and here you can launch your existing Python scripts. So it's the way to launch JupyterNotebook. Okay, until now I explained how to launch JupyterNotebook. And to finalize the installation of a JupyterNotebook, you need to install some packages. I put those packages in one-time installation script. And so it's better to have one path in your laptop and put all of your Python script there, and some extra Python script like one-time installation and template that I explain what are those. Python script. So now I want to explain how to finalize the installation of a Jupyter Notebook. Until now, I explained how to launch a Jupyter Notebook and how to launch an existing Python script. But to run your Python code, you need to first install some packages. I put those packages in one-time installation. So let me launch a Jupyter Notebook and I explain you how to install those packages. So I launch Jupyter Notebook. Then I go to the place that I store my script, sure here. And here I have one-time installation, just open one-time installation. I will provide this script in my channel again. So here you need to install 7 packages. So in each cell I provide the packages. So here you just click inside of the cell and run and wait until this message pops up, then shows that installation is done. Again, go to the next cell and then press run, then wait until this message pops out. Go to the cell 3, run, cell 4, run, this cell run, this cell run, and this cell run. So by running these cells, you will done with installation of a Jupyter Notebook. The installation of these 7 packages will take around 10 or 20 minutes. So just click inside of each cell and press run and wait for the message. So in total, it will take around 10 till 20 minutes. So after installation of these packages, you are ready to run any Python scripts. And also we need to import some libraries. I store those libraries in a template script. Again, I will share this script in my channel. Python needs some libraries to analyze, manipulate, and clean the data. So these libraries, I put them in one cell. So you need to import these libraries before you're starting the coding. So these libraries like Panda is for some data-related functionality. I don't know, plotting. Matplot is to plot different plots in Python. Datetime is so for some date functionality. Math is for simple mathematical calculation. Time, again, time-related functions. We have Excel wings or what do you call Win32com. They are for connection of Python and Excel. So they are all libraries that we need to import for running our Python script. So at the beginning of every Python script, I have these libraries. So if you look at a script of chapter 1, chapter 2, or 3, you will see the first cell are important of those libraries. So whenever I want to start create a Python script, just I make a copy from this template. Let's say it is a template. I say copy. For example, I want to make chapter 23. So I call here chapter 23. I don't know the name of the chapter. Then I have a copy of template. So it is a copy of template. So I just open it by Jupyter Notebook. Then I see this page. So you see it is chapter 23. In chapter 23, the first cell, I will see those libraries. So then from cell 2 onward, I will start coding. Okay. So for every script, I have in first cell importing of these libraries. And from cell 2 onward, I start my main coding. So that's all for setting up a Jupyter Notebook. Okay, let's get started with chapter 1 and different data types and reading data from Excel and Access databases. I already explained how to set up a Jupyter Notebook, how to install different packages, and also explain how to import required libraries in Python. Now I want to launch the corresponding Python script of chapter 1 and start to explain important topics. Okay, first I launch Anaconda Navigator. I already pinned Anaconda Navigator here. I launch it. So you need to wait until 1 minute to the Anaconda Navigator pops up. Still launching. Okay, we have Anaconda Navigator here. and I launch Jupyter Notebook, then I find the corresponding Python script of chapter 1 that I save it in desktop, Python training main script chapter 1. See, it is in my desktop. It's the same path as here, Python scripts, and here the script of each chapter. So I launch the Python script of chapter 1. As I explained, in the first cell we import some libraries. So you need to click inside of the cell and press run. By this running, actually you import these required libraries. As you see, there's one star here. When you click run inside of a cell, and the star appears, and when appears a number, that means the run of that cell is finished. Okay. Now let's start with simple math calculation. First, I start with simple topics in Python, and over next chapters I cover more advanced topics. Okay, so let's start with simple mathematical calculation in Python. How to do multiplication, or how to subtract or add some numbers. So, for example, 2 plus 5, 7. So here in every cell in Python, you can write some simple mathematical calculation. Okay, so we call it cell. It is one cell, it's another cell, and it's another cell. So every cell you can write down your Python code. So I start with simple one. 2 plus 5 is 7. And if you run a cell, you can press run here, or you can press shift enter inside of the cell. So if I want to run this cell, I can press run. And next cell, for example, if I want to run this one, I can keep shift and press enter. Okay, so 2 plus 5, 7, 8 minus 6, 2, 4 times 6, 24, 8 divided by 3, 2.66. Remainder of 8 by 3 is 2. Remainder actually is the integer part of division. 8 divided by 3 is 2.6, and integer part is 2. Okay, power 2 to the power 5, it means 2 times 2 times 2 times 2 and times 2 means 2 to the power 5, which is 32. Okay, and this number that you see in the left hand side is the sequence of your run. So in the first cell I import some libraries, it is 1, and it is the second cell that I run, it is the third cell that I run, so if I run this cell again, you can see the sequence number becomes 8, and if I run this cell again, the sequence number becomes 9. Okay, so these number can help you in which sequence you run your code. And if you want to add a cell above or below a specific cell, you can do it in this way. So you can click on the left hand side of the cell. Whenever you are inside of the cell, you see a green bar, and if you click on the left hand side of the cell, you see a blue bar. So by clicking on the left hand side of the cell, you see a blue bar, then you can press A. By clicking A, you add some cells above that cell. And if you want to add some cells below this cell, again you press on the left hand side and click B. So by clicking B, you add some cells below that cell. And if you want to delete those cells, again you click on the left hand side and press X. By pressing X, actually you delete those cells. There is another option. You can press plus here, then you see you will insert some cells, and if you want to delete them, you press this icon and you can cut those cells. So they are the simple mathematical calculation by Python. Okay, next goes to the next topic, which is a scalar or a variable. A scalar or a variable is a quantity that is described by its magnitude. A scalar can take only one value. For example, your weight, the number of employees in one company. So your weight can take only one value. You cannot say my weight is 22 kilograms and 82 kilograms. No, your weight takes only one value. The number of employees in one company can take only one value. Okay, the volume of a part, okay, can take only one value. And now I want to explain how to define a scalar and a variable in Python. And I try to explain it through examples. Here I want to define the man that takes a value of 45. To define a variable, I mean to name a variable, you should not define a variable by a number. Okay, you should not start defining a variable with a number. So one demand, because of one at the beginning of the name of the variable, is not a valid naming. So if I run this cell, you say invalid syntax because of this one. So you cannot define a name of variable with a number. You can start to have a number in the middle, but should not start with one. You should not use space when you want to define a variable. So periodic demand, for example, is one variable that takes value of 9. If I run this cell, you see invalid syntax. Again, because of this space, you receive an error. You cannot use special characters like dollars, I don't know, question mark, slash. Those one are special characters. You cannot use special characters when you want to define a variable. So here again, invalid syntax. The only special characters that you can use when you want to define a variable is underline. Okay, underline is valid. So when I run this cell, you say demand takes value of 7, and when I print demand, it takes only value of 7. So it's a valid naming. You cannot use comma when you define a variable. So here I use comma. If I run it again, invalid syntax. You cannot use dash. Okay, you cannot use question mark. You cannot use dot. All of them are invalid. So here we have a valid naming for a scalar. No space, no special character, no question mark, no dot, no number at the beginning of a variable. So it is a valid naming. So the weekly demand takes value of 5, and when I print it, you can see it shows the value of 5. Periodic demand, it's a scalar or variable that takes the value of 7, and it's a valid naming because there's no space, no special character, no number at the beginning of the variable. So it's a valid naming, and periodic demand takes value of 7. Weekly demand, look, I use a special character, underline. Underline, as I explained, is only a special character that you can use when you define a variable. So weekly demand here is 8, and when I print it, you see the value of 8. Okay, you can use number when you define a variable, but not at the beginning of the variable. So here var1 takes the value of 34, and you can do some calculation when you define a variable. For example, var1 plus 7. So var1 is defined here as 34. 34 plus 7 is 41. var1 times 2. So var1 is defined here 34. 34 times 2 is 68. And here I want to say var1 to power 3. When I run, they say var1 is not defined. So maybe somebody say, okay, I define here var1, but why receive error here that var1 is not defined? Here I want to explain that Python is case sensitive. Here I define var1 with capital V at the beginning, but here we see small letters. So this var1 in cell 26 is different from var1 in cell 29 because this V is a small letter, and here I have a capital letter. So here var1 is not defined. If I use a capital letter here, you see var to power 3. It means 34 to power 3. Here I can say var1 plus 6, and I assign it to another variable that I call it var2. So var1 is 34, 34 plus 6 is 40, and I can print 40. var1 divided by 6, 34 divided by 6, and I assign it to variable 3, then variable 3 becomes 5.66. Here I can define var1, var1 divided by 6, and I assign it to variable 4, and I have the value of 4. Okay, so if I want to summarize define a scalar variable, here I can summarize the notes. When you want to define a variable, you should not use a number at the beginning of a variable. So 1 var and 2 var are not valid naming. Do not use space. So total profit because of this space, number of employees because of these spaces are not valid naming. Do not use special characters. Never ever use these special characters when you define a variable. Do not use indent at the beginning of a line. Indent is a space at the beginning of a line. Okay, if you use let's say a space at the beginning or a tab at the beginning, so we call them indent. You never use space at the beginning of a variable. So my recommendation is that never ever use a space in defining a variable. Don't use comma. So here is comma, so it's not a variable naming. You can not use dash. but you can use underline. Okay, underline is the only special characters that you can use when you define a variable. You can use numbers, but not at the beginning var. So var1 and var2 are valid, but if you use one var and two var, they are not valid. And I have some notes also here. Python is case sensitive, as I explained. So total profit one is different from total profit because of this P. So here we have capital P and here I have small p. So these two variables are different. And note two, so here I can see the way that I define a variable. So when you have a variable that has two components or two, let's say, words, I use a big letters or capital letters when I want to have a let's say transparent naming. So here I can say total profit. I use a capital T and capital P, or I can use underline to show, okay, it is total profit. Or you want to say weekly demand, you can use capital letters like W and D to show, okay, it is weekly demand, or you can use underline. Okay, don't use space or special characters or dot at the middle of these two components. Okay, use capital letters or use underline to make a transparent naming when you want to have a variable with two components. So they are all nodes when you want to define a variable or a scalar in Python. Okay, we go to the next topic, which is print function. So I try to explain again print function through examples. Sometimes while you're coding, you want to print a special statement in part of your code. To do so, you can use print function. In print function, actually, you can write a statement between quotation and write the desired statement that you want. Here, I want to print, this is the output of my code, in some part of my code, and I write that statement between a quotation, and here you can see the output. When you use quotation, you cannot use a special character or you cannot use inter when you want to print a statement. As you see here, I put up one inter and I receive an error. If you want to use a special character or inter in your statement, you should use triple quotation at the beginning and at the end of your statement. So my recommendation is to use always triple quotation when you want to use a print function. When you use a print function by triple quotation, then you are allowed to enter and write your statement here, your statement, and even any kind of inter or space, or you can use any special character here. So if I use a print function, you see the way that you enter the characters here, you will see as a output. So always use a triple quotation when you want to have more flexibility, when you want to have inter or special characters in your statement. So never use quotation and always use triple quotation when you want to use a print function. Next, sometimes you want to have a dynamic variables when you want to print a statement. For example, here I want to print this statement, but here I have a variable that over the time that variable may change. So here I can use a dynamic variable. I call it var name, and by this format I can put actually part one to this variable. So how this function works, actually here I put var name as a dynamic variable and I assign part one to that variable. And when I print this statement, as you see here, you see this is the output of training part one. So var name is replaced by part one. I call it dot format method. You can use also numerical values. For example, total revenue is 3020. Here you can see the total revenue is var name, and var name is total revenue. What's total revenue is 3020, and 3020 will be replaced by var name. And when I print the statement, you can see here the var name is replaced by 3020. Another method to have dynamic variables in print function is f method. I call it f method. So it's very easy method. You can use f at the beginning of a statement and use a dynamic variable here. So you define var name here 23.7, and by using f method you can have a dynamic variable. As you see, var name is replaced by 23.7. F method has a more flexibility. You can define the format of output as well. If I define var name as 23.74 until 3 decimals, then I can define here, okay, the format of output should be until 3 decimals. As you see, Here, the output I see until 3 decimals. And if you want to have it in nearest integer, you can put here 0f instead of 3f. So if I put 0f, the output will be 24, which is nearest integer to 23.74, as you see as output. And finally, when you want to combine two statements, you can easily use sum operation to combine two statements. For example, here is a statement A that shows we cover basic advanced topics in Python, and a statement B after this training, blah, blah. Then I can combine these two statements and print as a single output in a print function. So it's the way that print function works. So here we can summarize the notes related to print function. So when you want to print a static statement, you can use quotation, as you see, but you can use triple quotation to have more flexibility to use the special characters and inter, as I explained. And to have a dynamic statement, you can use two methods. One is dot format method, which is this is the syntax of using dot format, or you can use f method. And in f method, you have flexibility to define also the format of output, to how many decimals you want to show numerical values, for example. So that's all about a print function when you want to print a special statement in part of your code. So f method is one of the interesting methods. Later I will use f method. This is very interesting method for printing a statement. Okay, before explaining the next topic, let me explain the case study. I use these case study to explain almost all topics in all chapters. So this case study is a supply chain problem. Let's suppose that we are managing 3 warehouses. Those warehouses receive products from some suppliers, and we sell products from warehouses to retailers. So in this supply chain problem, we have 3 warehouses, 20 suppliers, and 12 retailers. Let's say, for example, it is a supplier. Suppliers can be manufacturer. These are warehouses, and they are the set of retailers that we have. And for this case study, we have a data set. I use the Access database and Excel file to represent our input data. So let me open the data and explain the input data. In this input data, actually, I have data related to all supply chain entities, which is warehouses, suppliers, and retailers. So here is suppliers information, warehouses, retailers, items, purchase order lines, etc. So later I explain the details of this input data. We have also some data in Access. So I intentionally put them in Access and Excel to show how read data from an Access database and an Excel file. So here's the supplier table, and this is one purchase order line. Okay, so but before explaining the details of case study, let's explain the different data types that we have in data analysis. So there are 6 different data types that we can have. Let's start with float or integer. They are numerical values. Float actually is a variable that takes decimals. For example, length can be 20.4, 20.6. It can be also without decimals, 20. Height can be, I don't know, 78.6, or weight or price, that they can have decimals. Integer is a float that cannot have decimals. It's only integer. Sales quantity. So we cannot say we have sales quantity of 24.6 or 28.9. So we can say sales quantity is 10, 12, 28, 10,000. Number of employees. We cannot say we have 3.6 employee or 10.8 employees. Number of employees can be 100, 200, 250. On hand quantity. How many items you have on stock. You cannot say you have 3.6 pieces on stock. Okay, so float are the numbers that can take decimals, and integer are numbers that cannot take decimals. String or text are the variables that are in the string or text format. For example, your name, your address are in text format. Phone number, maybe somebody say phone number is a number, but a phone number doesn't show a quantity. Look, float and integer shows the quantity. The variables that that can be bigger or smaller or equal. I mean, you can compare them, but the string, you cannot compare them. You cannot say your phone number is greater than my phone number. But for sales quantity, if I give you two numbers, you can compare, okay, this number is greater than that number. So it's the way to understand a variable is really float, integer, or a string. So if you cannot compare two variables and can say, okay, this one is greater than or equal to that one, it's a string or a text. And if you can compare them, they are in the float or integer format. So your phone number is not a, integer or float, it's a string. Your ID, everybody has an ID. Okay, that ID is a string, is not a number. Boolean is a variable that takes only two values. When you play a game, you will win or you will lose. So you have two outputs. When you have a customer, you will miss a customer or you will meet a customer. True or false, 0 or 1. So any variable that can take only two values, we call them Boolean. Okay, when you throw a coin, that coin can be head or tail. So it has only two values. Date, so it's clear every variable has a date format, order date, arrival date, departure date, I don't know, date of birth, and they are in the date format. And null, they are the variables that take nothing or any records in the data that are empty, no values, we call them null or empty records. So now I explain different data types. Now we will back to our case study and the data related to the case study and explain different data types for each table. So as I explained, here we have 3 warehouses, 20 suppliers, and 12 retailers. So here are our suppliers. So every supplier has a supplier code, has a supplier name. It is the country of the supplier, city of the supplier. Those supplier deliver to one of our warehouses, the email address of the supplier, phone number, is it a manufacturer or not, and reference that shows, I think, the combination of country, supplier code, and city, something like this. So here let's see what kind of data type we have. So supplier code is a code. Is that the quantity that we compare, that say, okay, this supplier code is greater than this supplier code? No. So is it date? No. Is it a let's say null? No, it's not null. You see some quantities here. So it is a string format. As you see here, we have different data types. They are not integer, float, they are not Boolean, they are not date, so it is string. So it is a text. Okay, maybe somebody say, okay, it's not a text, but it is a string format. It's a text format. Supplier name is clear that it's text format. Country is a text format. City text format. Delivery warehouse text format. Email address is text format. Phone number text format. Manufacturer, as you see, manufacturer can take only two value. Is that supplier is a manufacturer or not? So it's a Boolean. And reference, of course, is in a text format or string format. We have 3 warehouses. This is the size of warehouse, address of warehouse, and number of items in warehouse. So warehouse name is a string, size of warehouse is an integer, address a string, and number of items are integers. Retailers, we have 12 retailers. Retailer number, again, these numbers doesn't show a quantity of the retailers, or cannot say, okay, this retailer number is greater than this retailer. So they are in string format. Country of the retailer is a string format. Size of the retailer, integer. Delivering warehouse, string. Manager, string. Address, string. Number of items, integer. Number of employees, integer. And construction date. Okay, I need to explain something here. Construction date, maybe somebody say, okay, it's a date format, but yeah, the content of the data should be in a date format, but as you see, it is in number format. So you cannot say it is a date. So the content of the table should be in date, but data type in this column is integer. Okay, be careful when you handling the data. Here I see also one example. Here, for example, manufacturing is a Boolean. I mean, the content of the column is Boolean, but as you see here, it's written true and false. So they are in a string format. So this column is in string format, but content of the column is in a Boolean.
So later in Python, I will explain you how to understand what is the data type inside of one column. Okay, now I want to explain you what the difference between data type is. Okay, later I will explain you how to understand what is exactly the different data type in different columns. So we have a table of items that every item has item number, item name, in which warehouse that item is stored, sales code, how many on hand we have, weekly demand, size of the part. So they are item level information. What's the weight of the part in gram? What's the selling price? Lead time, sorry, lifetime, on shelf time, and which date we put the part on the shelves. What's the category? We have different category for part. They are vegetables, fruits, or furniture. Demand class ABC based on the demand rate. The higher demand, the higher class. The parts at higher demand are class A. The parts with low demand are class C and B in between. Lead time is the time that takes to buy items from supplier. So just go to the data to understand what is inside of the table, because I use these tables a lot for my uh, coding to different chapters. So we have purchase order line. This purchase order line shows the quantity that I purchased over time from our suppliers. So every purchase order line has an ID. So for example, this purchase order line shows, okay, I bought this item number from this supplier. I ordered at this date, at this promised delivery date by supplier. Status of this purchase order line is not defined. Lead time is 3 weeks. Arrive date is in 29th of January, and the quantity that we order is 701. So they are the lines that we purchase from suppliers. And customer order lines in 2022 and customer order lines in 2023 shows our retail customer. Look here, if I back here, so purchase order lines is the quantity that warehouse purchase from supplier, and custom order lines are the lines that retailer buys from warehouses. So custom order lines, for example, let me see what this line says. So it means, okay, this is the idea of the line. This retailer with this code bought this item with this number. This is the date of order in 4th of December. That customer bought this item, and we could meet that customer order, and the customer order was 309. So it shows all custom order line in 2022, and it shows custom order line in 2023. Inventory projection shows the inventory on hand over time. As you see here, it is 2023, and it shows the on hand inventory per category. So here, for example, if I filter on bread, I can see, okay, how the inventory of bread change over time. Okay, we call them inventory projection actually. And finally, we have date conversion. So actually, every company has a date conversion table that convert a specific date to corresponding week, month, and period in that company. For example, if I select a specific date in this calendar, let's say if I select 22nd of April, so 22nd of April is week 70 in year 20, and this period 5 in year 20. So this calendar, I can say this table is a predefined table almost in every company. They call it date conversion table. Okay, so date conversion table is a table that shows corresponding week, corresponding month, and corresponding period of a specific date in time. Here, I think I have date until next 10 years, like yes, until 2030. So I use also this table to find some corresponding week and period number for some specific dates. So I will share this Excel file in my channel. So please go through the data to understand the content of the data, what is inside of each tab. Okay, and one more thing that I want to explain here. If you see some pollution in data, for example, here you see some extra space at the beginning or in the middle. I did those pollution intentionally because later in one chapter I want to explain how to clean data, how to get rid of these pollution in data. For example, in some tables you see null values. You see here null values. Null means empty values. I want to explain how to get rid of these null value. So if you see some pollution in data, I did it intentionally because I want to explain it over next chapter. So again, please go through this Excel file and understand the data. Just go through different columns, do the filtering to understand what each column says. And in next topic, I want to explain how to read Excel and Access tables. As I explained, we have some input data in one Excel file, input data, in one Access database, Access input. Here you can see different tabs in Excel file and two tables that we have in Access database. First, I want to explain how to read different tabs in one Excel file. So it's very simple. Let's go to our Python script. The first step is to read the path of your Excel file. So it's very simple. You can go to your Excel file, just click on it and then copy path, and you can paste it here to have your path of Excel file. And next, you need to read different tabs in your Excel file. First, I want to read tabs retailers, for example. Here we have tab retailers. It should be the same as the tab name. So in tab retailers, I just say, okay, go to the file path, which is defined here, and go and read sheet name retailers and store the result of, let's say, this tab to one data frame. And here you can define the name of your data frame. So if I print retailers underline data frame, you will see is the same as tab retail. So you can read different tabs also similarly. So here I read the tab warehouses. We have tab warehouses. You see I use again the same as this one. And here I store the tab of warehouses in warehouse data frame. Let's print the tab warehouse data frame. Here you can see is the same as this tab. And similarly, we read tab items and we store the result in item data frame. So here I have item data frame. So again, it's the same as this tab. As you see, when the data frame becomes large, Python shows only the first 5 rows and last 5 rows, and in between just shows 3 dots. But if you have a short data frame, like warehouses, you see it shows all data frame. One important thing that I want to explain, how Python understand that, okay, what's the range of retailers? For example, how Python understand, okay, he needs to read only this range. Python always look at the last field row and he select the range based on that row. So here the last row which is filled in all columns is row 30. So Python understand, okay, row 30 is the last row that is filled, then it select that range as a range of data frame. If you have, for example, a table like this, let's say it is filled like this. Let me insert some random numbers here. Okay, what is the last row which is filled here? It is row 22. So Python will read this one as a data frame. I mean, you have a data frame with these columns and 21 rows. Okay, because the last row which is filled is this row and the rest will be null. So these values here will be null values. Okay, let's back to the original data frame that we have. And similarly, we can read tabs purchase orders 2023, which is here, and customer orders 2023, which is here, and tab date conversion, which is here. So here we write the name of tab name, sheet name, and here we define our data frame name. Okay, to summarize how to read Excel file, it's very simple. As I explained, you need to first define the file path, your Excel file path. Then you use this syntax. The file path is the same as here, and you define the sheet name here, and then you define a data frame name. That data frame name should be transparent. For example, when you read a tab item, you should give a transparent name that during your coding you understand, okay, that name shows the tab of item in Excel file. So with naming, be careful and be transparent. So we explained how to read different tabs in one Excel file. Now I want to explain one exceptional case. As you see in all tabs, the table starts from cell A1. See, all of them start from cell A1. But in some cases, like suppliers table, the table doesn't start from cell A1. So in this case, it starts from cell D8, for example. In this case, if you read the data frame, I mean the tab suppliers, here I read the tab suppliers. As you see, the data frame is not well formatted. As you see, the column names are not defined. We have a lot of null values. The column names actually are here. So it's not a well formatted data frame. So in this case, we need to tell the Python, okay, skip some rows and read a specific range in that tab of Excel file. So here I can define those criteria actually. Here I read the file path, I read the sheet name suppliers, and I tell the Python, okay, skip the first 7 rows and only read columns D until J. So if we go to tab suppliers, and if we skip the first 7 rows, 1, 2, 3, 4, 5, 6, 7, actually Python from row 8 onward start to read a table in a tab. And we define that read the columns, only column D until J. So column D until J. So actually it is the range that we read the data frame. And we don't need to define the last row again. So now it's a result. It's a well formatted data frame. Here are the columns and it is a table. And sometimes we can define a specific columns that we want to read. Here we define the range of columns. We say D until J. Here we can say, okay, read columns D, E, H, and J. So here we read columns D, E, H, and J. So here's the resulting data frame. And sometimes we can define the number of rows that we want to read. Here again in tab suppliers, we skip the first 7 rows. We read columns D until J, and we read only the first 5 rows. So here we read the first 5 rows, which are here. So it's the resulting data frame. Okay, to summarize our, let's say, syntaxing. First, I explain how to read a whole sheet in one data frame. If the sheet starts from cell A1, it's the way to read it. But if that table in one tab doesn't start from cell A1, you need to define Python, okay, how many rows it needs to skip and how many columns or which range of columns it needs to read. You can define also the number of rows, but if you don't define the number of rows, Python as a default can set the last row field in that table, in that tab, and you read that range as a range of data frame. And in next topic, I want to explain how to read a table from an Access database. So as I explained, we have 2 tables in one Access database, just suppliers tables and purchase orders. They are the same table as we have in Excel file. I just paste them here to show how we read these 2 tables from an Access database. So to read a table from an Access database, we have 2 steps. The step 1 is to connect to an Access database. It is the way to connect to an Access database. Here you just need to replace the path of your Access database, which is AccessInput. As I explained here, we have AccessInput. So in step 1, actually we connect to our Access database, and I call it AccessCon. It is the name of our connection. And the next step, we read the table. So here we say, okay, in AccessCon, which is here, read access query. And what is access query? Access query says select all columns from suppliers table. So that star means all columns. So select all columns from suppliers table. And these suppliers should be the same as suppliers here, which is the table name. And we call the resulting data frame as suppliers underline data frame 5. And you see the resulting data frame, which is the same as this table. Sometimes you want to read specific columns in one access table. So again, we have access con. This access con is the same as here. So we are connected to our access database. We don't need to have a connection again. And we have access query. We just need to change our access query. In access query, say select this column, supplier code, city, delivery warehouse phone from supplier table. So it's the way to define specific columns in one access table. So one thing that I want to mention here, be careful about this triple quotation. You need to write your access query in triple quotation at the beginning and at the end of your access query. You see these triple quotation, and you need to put your column name in a quotation. As you see, all column names are between quotation, and also the access table. And I call the resulting data frame as suppliers underline data frame 6. As you see, I just read 4 columns in this access table. And we have another table, as you see here, purchase orders. Again, here I say, okay, use access con. Access con again is connection to this access database. I don't need to connect again, and use this access query. What is this access query? Access query says select all columns from purchase orders. Look, this access query is just a name. You can call it access query 2, but this one also should be access query 2. Actually, this access query 2 is replaced by this one. So this access query says read all columns from purchase order line table. And I call the resulting data frame as purchase orders underline data frame 1. And this is the resulting data frame, which is the same as this table. So we can summarize how to read a table from Access database. As I explained, the first step is to connect an Access database, and here you need to replace the Access database path. And the second step is to replace the table name and assign a specific name to resulting data frame. And I also explain how to read the specific columns in one Access table. Okay, you need to just replace column 1, 2, etc. Here. And next topic, which is very important, I want to explain how to read an access table under some condition. So if you want to read an access table with a specific column, let's say column 1, 2, and 3 from table name, under some condition on columns actually. So here you can use where and define your condition. And the format of this condition actually depends on the data type that we have in that column. And here I want to explain how to do this conditioning on different data types that we have. For example, one want to have a specific conditioning on string variables. So if you want to say a string variable should be equal to some specific values like string 1, string 2, and string 3, so you need to use these syntax. Or if you want to say a string variable should not be equal to some specific values, you need to use syntaxing. And for numerical values, if you want to say a specific variable with numerical quantity like sales quantity, number of employees, should be equal to a specific quantity, is syntaxing, greater than equal to a quantity, less than equal to, or not equal to some quantity. And for date format, if you want to say a variable with date format like arrive date should equal to a specific date, or should be greater than or on specific date, or less than or on a specific date, or a date variable between a specific range, then you need to use this syntaxing. And for null variables, if you want to say variables is null or is not null, you need to use this syntaxing. So as you see, the conditioning that we have here when you read an access table depends on data type. Now I want to explain through examples how to use these conditioning by using these two tables. Here, for example, I want to read a purchase orders table. Purchase orders table is in Access database, this table. And I want to say read all columns from purchase orders where means a condition where in a status column is delivered or ordered. So in a status column here, we have different possibility: cancel, deliver, dispatch, and order. So we want to say to Python, read purchase order tables where means under the condition that status is only delivered or ordered. So the resulting data frame is purchase order data frame 2. And if we see the status column is ordered or delivered, as you see, ordered or delivered. And I print the resulting data frame here to one Excel file. Later I explain how to print a resulting data frame to an Excel file. For now, is just skip it. Let's go to the result, which is in this path. It is in Python training main, some input, purchase order line data frame 2. Python training, some input, purchase order data frame 2. Let's go here. So this data frame, let's do filtering now in status. As you see, it is delivered or ordered. Okay. So here we read a supplier table where status is delivered or ordered. As you see, the status is delivered or ordered. And in next example, I want to say read all columns from purchase orders where supplier code is not equal to one of these three values. Okay, it means supplier code is not equal to this one, supplier code is not equal to this one, and supplier code is not equal to this one. Okay, be careful about this condition. So this condition means supplier code is not equal to these quantities. And here status is delivered or ordered, as you see the resulting data frame. So let's see the resulting data frame for this example that we say supply code should not be equal to one of these three. I store the resulting data frame to purchase order data frame 3, and I store them in purchase order data frame 3. So let's go to data frame 3. So as you see, we should not have supplier code equal to one of these values. Let's check. Supplier code is here. So supplier code is not equal to this. Supplier code, this value. So no supplier code, this value, and no supplier code with this value. So the filtering works properly, and supplier code is not equal to these three values. As you see, the resulting data frame has 712 rows. In purchase order line, the original one, how many rows we have? We have 1,000 rows. So you see the resulting data frame by this conditioning has a less number of rows. And in the previous example, we have 503 rows. So by this conditioning, we have a less number of rows. And in next example, I want to say how to have different condition. I mean, here we want to say, okay, select all columns from purchase orders where status is not null and supplier code is one of these three values. And I again store the resulting data frame to a data frame 4, and I print them in this data frame. Okay, let's go to that data frame, which is again in some input here, data frame 4. So the resulting data frame is data frame 4. So status is not null. So in the status column, you should not see any null values. I see all of them are filled. However, previously we had some null values. Let's see, like this one. We filter out those columns actually. So in this part of the code, we say status is not null and supplier code is in. So supplier code takes only these three values. So if I check here supply code, you see the supply code takes only these three values we mentioned here. And the number of rows in the resulting data frame is around 288 rows. And the next example, which we call it purchase order line data frame 5, we call purchase order lines where status is null. So as you see, we have only one rows that shows status is null. If you go to the purchase order line, and if you select the blank, that blank shows null value. We have only one row, purchase order line ID 14, and it is the only row that has a status null. And let's see some more examples. So in this case, I want to read some specific columns. Let's say these columns: item number, supplier code, order date, arrive date, and order quantity from purchase orders table. So it is purchase order tables, item number, supplier code, order date, arrive date and order quantity. I want to read these columns from these purchase order tables under two conditions. One of the condition is that item number should be 7016 and arrive date should be after 15th of July 2023. So any records that hold these two conditions at the same time will be in output. So as I see, I report them in data frame 6, and when I print the data frame 6, you see item number. Let's look at the condition. Item number is 7016, and at the same time, arrive date is after 15th of July 2023. Look at the arrive date. Arrive date is always 15th of July 2023 or after that. So it's one example. Another example, I want to read some specific columns again. These columns from purchase order table in Access database under two conditions. One of the condition is that lead time is not equal to 4. Lead time is not equal to 4. And order date is between 21st of March 2023 and before 28th of May 2023. So order date is in this period of time. Please note that here 21st of March and 28th of May are included in the filtering. So you will report actually the records where lead time is not equal to 4 and order date is in this period of time. And I export the resulting data frame to purchase orders data frame 7, and I export it to purchase order data frame 7 Excel file. And here you can see the output. Let's see if the filtering works properly. So in data frame 7, actually I did two filterings. One, lead time is not equal to 4 and order date is in this period of time. So lead time, as you see, lead time is not equal to 4. Lead time takes only 1, 2, 3, 5, and 6. And order date is after 21st of March and before 28th of May. Let's say order date after 21st of March, as you see, and before 28th of May. So as you see, the filters works properly. And another example. So in example number 8, again, I want to read specific columns from purchase order table under two conditions, where lead time is greater than 3 or arrive date is after 22nd of August 2023. And here I have or condition. So here you can see the difference between or and condition. When we say or condition, it means either of these conditions should hold. I mean, lead time greater than 3 or arrive date after 22nd of August. And whenever you have and condition, it means both conditions should hold at the same time. So let's see the output of this one. When you have or condition, I use data frame 8 as output. So let's see the output in data frame 8. Okay, so if you look at the records in data frame 8, you see either of these conditions will hold. I mean, you will see or lead time is greater than 3 or arrive date is after 22nd of August. So let's see some records. For example, in this case, do I do filter on? Yes, arrive date. I need to look at arrive date. So arrive date, is it after 22nd of August? No. So we look at lead time. Lead time is greater than 3? Yes. So one of these condition holds, in this case, condition 1, which is lead time greater than 3, then it is in the output. Second one, is it after 22nd of August? Yes. So that should be in the output. Lead time also is greater than 3, as you see here in both condition holds. But if either of those condition holds, you will see a record appears here. So 9th of September, so it's after 22nd of August. I don't need to check the other condition, so it's in the output. Here it is after 22nd of August. It is after 22nd of August 2023. Let's see one example. Here, for example, it's not after 22nd of August, but lead time is greater than 3. So this case, lead time is not greater than 3, but arrive date is after 22nd of August 2023. So as you see, in records here, either of these condition holds. Okay, then let's back to our slides to explain how to read one access table under condition. So here I explained in previous slide, I explained how to read one access table. As I explained, to read one access table, you need to do two steps. One of the steps is to connect to an access database. I explained here. I explained how to read all columns in one access database. I explained how to read specific columns in one access database. And here I want to explain how to read access table under condition. I already provided you the examples. And now I want to summarize the syntaxing. So here I write access query. Here you can define the columns that you want to read from table name. And this table name is the access table name. Here in this example, purchase order is the table name and column name is item number, supplier code, order date. So, and here you can write your condition. And these condition depends on your data type. If you want to do filtering on a string variable, you have these two conditions, which is a string variable in equal to some values. Here we have some examples. Let's see. For example, here I say item number in equal to that value. And here I say supplier code is in these three values. Or you can write also not in. When you say not in, it means it should not be those values. I think we had one example also here. Yes, supply code should not be one of these three values. And if you want to do filtering on quantities, I mean numerical values, you need to do this filtering. And here we had filtering, for example, on lead time. Lead time is a let's say quantitative variable. So lead time is not equal to 4. So I use this filtering. Or lead time greater than 3. Then I use actually this inequality. For date, so it is the format of date when you want to filter. So date is equal to one specific date, date after a specific date, date before a specific date, and date in the period of time. And here we had example. For example, arrive date after 22nd of August 2023. And in example 7, we have order date in a specific period of time. And if you want to filter on a variable which is null or not null, it is the syntax that you need to use. And here I think we had one example about status. Yeah, status is not null, then it means just report the records where status is not null. Or in this case, say report the records that status is null. So here may somebody ask why we do this filtering when you want to read one access table. And the other question is that how to understand the data type. I mean, we do this filtering based on data type. How can I understand, for example, here the supply code is in the text format or number format? Or here arrive date is really in the date format. So I want to answer these two questions. First, I address the first question that why we do this kind of filtering while we are reading access table. Sometimes you are encountering with big tables with millions of records. So in that case, maybe you need to read only a specific records in that table. For example, you have a customer order line table that shows all customer order line from 2003 until today. So it's more than 20 years of record, and maybe you see millions of record in that table. So in that case, maybe you need to filter on order date. They say, okay, order date should be after 2022, for example, and read only a specific range of data, not the whole table. If you want to read the whole table with millions of record, then it is time consuming. So in that case, we have 1,000 records, maybe it's not time consuming to read the whole records. But if you have millions of records, then you need to focus on the columns that help you to just filter out some columns and read just a specific range of records. So it's the reason that I explained the filtering while you are reading an access table. And the second question was how to understand the data type, because the filtering and conditions that you write here depends on the data type. When you have a string variables, you need to do this kind of filtering. For numerical or quantitative variables, you need to do this. And for date format, this kind of filtering. And for filtering on nulls, this. So if you go to Access database and open one access table and go to the design view, you will see here the data type. For example, the purchase ID is a number format. Then if it is a number format, you need to use this kind of filtering. So for purchase ID, lead time, and order quantity, you should use this type of filtering. I mean, your condition should be in this format. And if you want to do filtering on item number, which is in the short text, I mean string, supplier code is short text or string, and status also short text or string, then you need to do this kind of filtering. Okay, this is the way that do the filtering and write your condition. And if you have date format here, for example, for order date, promise delivery date, and arrive date, you need to use this kind of filtering. So it's the way to understand what's the data type point of your Access database. So until now, I explained how to read one Access table under condition. So next, let me explain how to create a data frame manually. So here, let's see example. I think by following the example, you can easily understand how I create this data frame manually, and I call it manual data frame. So here I define the columns, name, location, and age are columns, as you see here. And these one are the content of each column. So in column 1, we have 4 components, column 2, 4 components, and column 3, 4 components. Be careful if you enter, for example, 5 components in one of the column, you will receive an error that shows, okay, you are not following the number of index in the rest of column. And lastly, I want to explain some setting about your Jupyter Notebook cells. So I think I already explained how to add one cell above and below a cell. If you click on the left hand side of a cell and by pressing A, you can add some cell above. And if you click on the left hand side of the cell and click B, you will add some cells below. And if you click on the left hand side and press X, you can delete those cells. Here I want to explain how to write these notes. Sometimes you want to add a note. For example, here you want to write a specific note. Write a note here to explain, okay, what's the inside of this cell. So here, when you click inside of the cell, you have 2 formats. One of the format is code format, and one of them is a markdown format. If you want to write a typical Python code, you should be in the code format. As you see, if I click inside of these cells, you see a code format. But whenever you want to write a note, let's say it is inside of the cell and it is in the code format, if I run it, you will see an error. And if you want to make it as a note, you just make it markdown. And if you run it, you will see that one as a note. So if I go inside of this cell and I make it markdown, then it's not a Python code. Then it's only a text. Okay, now it's only a text. And if I go again inside of the cell and I make it in code format, then it becomes again a Python code. So here I explain different setting when you want to write a note. When you write a note here, let me again write a note and make it markdown. And by putting one hashtag here, you can make your note bigger and make it italic. If you make 2 hashtags, you can make it smaller. And here I provide some kind of text formatting. So if you put 2 stars, you make the text bold. If you take 1 star, you make it italic. Backslash, you mark some part of the text, and you can itemize also some bullets here. So if I run it, you will see the output, and by comparing the output and cell, you can see the result. And you can also upload an image. If you go inside of the cell, again, you make it in markdown and you go edit and insert image. You can browse one image, and just by running, you will see the image here. Sometimes I need image to explain my coding through one image. And lastly, you want to see a pops up message when the execution of your Python code has ended. So by this, let's say pops up message, you can understand, okay, the Python code execution is ended. Okay, you see end of run, which is the same as this message here, and we're pressing OK. Actually, understand that okay, the execution is end. So it was all setting about cell in Jupyter Notebook. You can make your script also as a PDF file, and you can finish the running of a code. For example, when you run it and you want to end the running, you just press this button to finish the execution of a cell. Or you can click on the left hand side and press I. I means interrupt, then you can interrupt your execution. So that's the end of chapter 1. If you have any question, you can write in comments. I will answer your questions as soon as possible.